Alright, this is lecture video for section 2.2. In this section, we're going to talk about fractions, and I gave you some vocabulary terms that you see here. Fraction is a numerator, a top number, and a denominator, which is a bottom number, that represents parts of a whole number. So a numerator is your top number, and I remember N for numerator as in north, so it tells me that it's the top number of a fraction, and it shows how many parts of the whole that we're talking about. The denominator, the bottom number, I remember D for down, of a fraction, shows how many parts are in the whole. So let's look at this picture here. I see a circle here with several parts sectioned off, so I'm going to count them. 1, 2, 3, 4, 5, 6, 7, and 8. So I already told you that the denominator show how many parts are in the whole, so that's 8. There's 8 whole parts. The numerator is how many parts we're talking about in a specific way. So in this picture, you see the red, and we see 1, 2, 3 parts that have been shaded, and so my numerator are how many parts have been shaded in this fraction. So 8/3 is what we have. Why is it 8 denominator? Because there's 8 pieces in the whole, and 3 are how many that have been shaded. Alright, so we are going to look at pictures and write our fractions from that. And remember, I'm a math person, I don't draw well, so just imagine that these pieces are perfectly sectioned off. 4, 5. Okay, so imagine that they are equal parts. Every little section that you see on this page are perfectly equal. Just imagine. Alright, so first of all, if I'm going to write a fraction for it, I kind of need to know what I'm dealing with here. So let's go ahead and Alright, so here's our image, here's our picture. So I'm going to write a fraction of the shaded parts. Well, the denominator, the bottom number, is 1, 2, 3, 4, 5, and 6. There's 6 pieces in the whole. So 6 is my denominator. There are 1, 2, 3, 4 pieces that are shaded, and so 4/6 is the fraction that represents the shaded parts. Alright, let's look at a circle. Again, I'm not a very good drawer here, so just imagine that these look great. Probably could have changed those colors. Alright, so here's our image or our picture. We're going to count the parts. 1, 2, 3, and 4. So I have 4 parts in the whole. How many are shaded? 1, 2, and 3. And so there's my 3/4 represents the picture that is shaded here. Alright, so for my picture, I want to know how many parts are shaded. So I know that there's 1 part shaded. I don't know what my denominator is yet, so I have to count them. 1, 2, 3, 4, 5, 6, 7, and 8. So 1/8 is shaded. So this is parts shaded. And this is parts in the whole. Okay. Okay, so we are looking for how many parts are shaded. So let's go through here and count. So here is 1, 2, 3, 4, 5, 6, and 7. 7 parts shaded. How many parts are in one whole? I pause because I want you to think about it. What I see here are 2 pictures. I want to know how many parts are in one whole. So here's my one whole. There are 1, 2, 3, and 4. So there are 7 4ths shaded in this picture. Does this make sense? Well, this is 1 whole, and this is a fraction, right? 3 out of 4. And this, a whole number and a fraction, is represented in fraction form when the top number, the numerator, is bigger than the denominator of the bottom number. And so this makes sense. It makes sense that there are more pieces that are shaded than there really are in 1 whole, because notice that there's more than 1 whole happening when we start our shading. We're imagining that these are exactly the same shape. All the pieces are equal. We're also pretending that my shading is beautiful. Good. All right. How many pieces are shaded? 1, 2, 3, and 4. 4 shaded pieces. How many pieces in 1 whole? 1 whole means 1 image, and I have 1, 2, 3. Does it make sense that the top number is bigger? Yes, because more than 1 whole is shaded, right? So there's an extra part, which means that the top number is going to be bigger when you write this fraction. So if I gave you a fraction, could you tell me which one is the numerator and which one is the denominator? Because your homework is set up to ask you those types of questions. So the numerator, remember, means north, and so if I could spell north, that'd be great. Would be 3. The denominator says down. Remember, that's how we're remembering which one's which. And so for this one, I know that 4 will be my denominator. My numerator is 8. My denominator is 5. Okay, numerator north, denominator down. That's how we're remembering these. All right, a little bit more vocabulary. Okay, so here's the next 2 vocabulary terms, a proper fraction and an improper fraction. And we briefly just talked about an improper fraction, and you really didn't even know it yet. So let's talk about these. A proper fraction, a numerator of a fraction, is less than the denominator, meaning the top number, the north number, is smaller. The whole fraction is less than 1 whole. So if we were shading a picture, you would not shade the whole picture or more than the whole picture. You would just shade a few parts of the picture or the image. The improper fraction is the numerator of a fraction is greater than the denominator, or it's equal to the denominator. The fraction is greater than or equal to 1 whole. So let's go through here and pick out which ones are proper fractions. The proper fractions that I see are here, 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 and here. There are 4 of them. These 4 blue arrow fractions here have a top number that is smaller than the bottom number, which is a numerator is less than the denominator. The other ones, here, 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 all 3 of these have a top number that is bigger than the bottom number, or a numerator that is greater than the denominator. This last one that I haven't actually colored yet, but I'm going to be very dramatic here and pointing it out. This guy is the same. The top number and the bottom number are exactly the same. And so in this picture, we go back to the definitions and we remember that the fraction, I can't underline it there. The fraction can be equal to 1 whole. So remember that when you divide 3 into 3, it goes 1 time, and so this is equal to 1 whole. So it can be greater than 1 or it can be equal to 1. So that's why the red arrow fractions are improper fractions. Okay, a few more vocabulary terms. Okay, mixed number is a whole number and a fraction written together. I don't know where that E came from, so I apologize. So when would we use these? So here's an example. Suppose that you have 3 whole trays of muffins and half of another tray. You would state this as a whole number and a fraction, which is a mixed number. So look right here in the blue. The 3 and 1/2 actually means 3 plus a half. So they're combined together by adding them together. So the picture below at the bottom is actually your trays of muffins. So notice that I'm showing you 4 trays of muffins where there's 2 parts in the whole. See right here I counted 1, 2 parts in every one of the trays. And you see them all shaded, right? We have 3 whole trays, so here is 3 whole trays, and then half of the other one. Why do I show you this picture? Because I want to count for you the number of pieces that are shaded. So here's 1, 2, 3, 4, 5, 6, and 7. So notice that I have 7 parts that are shaded out of how many? Well, what's the denominator? The denominator is going to be 2 because there's still 2 pieces in one whole, okay? What I'm trying to show you here is that 7 halves is the same thing as 3 and 1/2, right? 3 whole trays colored and half of another one, so that's 3 1/2. And we just counted it up and saw that there are 7 red pieces shaded, and there's only 2 parts in the whole. So 7 halves is the same thing as the 3 and 1/2. All right, this next part we are going to write mixed numbers as improper fractions, which is what I just showed you, right? Here's a mixed number, and then we just wrote it as an improper fraction. There's actually a few steps involved in this without having to draw pictures, so I'm going to type those out for you. Okay, so here are the steps. Write a mixed number as an improper fraction. Step 1, multiply the denominator and the whole number. Step 2, add the numerator to the answer from step 1. And step 3 is to write the answer from step 2 over the denominator of the mixed number that you started with. So here's our problem, 3 and 1/2. We're not going to walk away from it. We're going to actually show you the rules and show you the steps from using the problem that we've already worked. So I call this a backward C method. Okay, we start at the bottom here where I started drawing that C, and step 1 tells us to multiply the denominator, which is 2, and the whole number, which is 3. So I have 2 times 3, which is 6. Step 2 tells me to add the numerator to the answer that I just got. So here's that backward C method, right? I said I started down here and then I worked my way up. So I multiplied first and then I'm adding my numerator. So here's my plus 1 and I end up with 7. Write this answer from step 2, the 7 answer, over the denominator that you started with. And the denominator I started with was 2, and so this is where I get 7 halves from, right? 3 1/2 is 7 halves. We learned that in the first problem right here, right? Found the same answer with no pictures. We use the backwards C method. We multiply the denominator times the whole number and then add the numerator. Multiply first, then add, and I end up with 7. 7 goes over the denominator I already had, and so that's where I get 7 halves from. Let's try another one. All right, 7 2/3. I am going to multiply the denominator and the whole number. So 3 times 7 is 21. I'm going to add the numerator together, and so that's plus 2. 21 and 22 give me 23. I write this as a numerator over the denominator I already had. So 23/3 is my final answer. So let's try this one. I have 4 7/8. I'm going to use that backwards C just like we've been doing. We start at the bottom and work our way to the top. We're going to multiply here and then add the numerator. So I have 8 times 4 plus 7. I multiply first and I get 32. I add 7 and I get 39. I put that over the denominator I started the problem with, and so 39/8 is my answer. So what happens if we start a problem like this and they want us to work the other direction? Okay, so we're going to start problems like that. All right, so we're writing each improper fraction as a mixed number. So So what you have on the screen, the 17 over 5 is an improper fraction. So I want to remind you or to show you that a fraction bar means divide. And so for us to actually change this into a mixed number, we're going to divide 17 divided by 5. And when you write that out, it looks like this. The bottom number goes into the top number. And so 5 goes into 1 no times. 5 goes into 17 3 times. 3 times 5 is 15. I'm going to subtract and I get a remainder of 2. So the way that I do this is the whole number is 3 and it's the top number. The remainder is 2, that number down here, and it's the numerator of the fraction. And notice that the denominator that was already here will be the denominator of this problem. And so my final answer is saying that 17 over 5, or 17 fifths, is 3 2/5. How did I do that? I divided. Okay, we're changing 24 fourths into into a mixed number. So 4 does not go into 2, but 4 goes into 24 how many times? 6, because 6 times 4 is 24. I subtract and I get a remainder of 0. So we go through this again and we say the top number is my whole number. My remainder is my numerator. And my denominator that already was is the denominator of this answer. But what I want you to see here is that if you have a fraction with a numerator of 0, it means that you're not even talking about any pieces, right? Because this is actually a piece of pizza or a box of pizza where nothing has been eaten. So we're not even talking about a pizza, because so 6 is a whole number. Why do I know it's a whole number answer? Because I got a remainder of 0. There was nothing left over down here. So just that whole number of 6 is my final answer. All right, that's the end of section 2.2.